All right, so variables. Let's just start with the basics. Um, Say like I have a variable x. Let me make this variable something that we can all see. X. Um, well, in algebra you use variables for quantities that you don't know yet. So this x can represent anything. It could mean 10 billion. It could mean 1. It could mean 85. It could even mean 85 plus 2y. We don't know what this x represents, and it could represent anything, which is why it's called a variable. Its value varies. It depends on the situation, right? It depends on what you use x to represent. For example, maybe I have an equation 2x equals 10. I have another equation 3x equals 100 million. Twice x is 10. 3 times x is 100 million. Obviously, these x's don't stand for the same thing, right? These x's mean two different things. Well, a system of equations is a group of two or more equations in which the variables do mean the same thing. They have the same value um, across the equations. So for example, if I have two equations here, y equals 2x plus 3, y equals negative 3x minus 2, if I'm treating this as a system of equations, then I'm saying these x's have the same values and these y's have the same values. They mean the same thing. Um, so a system of equations is also called um, simultaneous equations. Simultaneous means at the same time, because you're dealing with these equations at the same time. And kind of a visual representation of that is, so these equations are linear equations and they can be graphed. So here I'm graphing the relationship between x and y. These lines are existing on the same coordinate plane right now. So the value of x, let's say, is the same for each equation. Or let's see, here, I know. Okay, if I'm talking, when x equals 1, oops, you can't really see that, can you? Here we go. This is gonna be sweet as soon as I fix it. Um, okay, I just need my visual tool. When x, so look at the x-axis here. This is the point at which x is 1. When x is 1 for this line, x is 1 for this line. If that makes sense. Maybe I'm doing a ton of stuff that is kind of unnecessary. When y is negative 2 for this line, y is negative 2 for this line. So the values of x and y are occurring at the same time, if that makes sense. So basically, a system of equations is a group of equations that you're dealing with at the same time, where the variables have the same meaning. So, and then the point at which they intersect, that would be called the solution of the system of equations. So they're really good for a lot of things. If you need to know, if you're trying to figure out the value of two variables, you need at least two equations in order to do that. If you've got one equation with two variables and that's all you've got, you can't solve that. You need at least as many equations as variables in order to solve them all. So if there's two unknowns that you're trying to find out, you need two equations. You need a system of equations. So an example of a problem like that is, classic, a boat traveled 200 miles downstream, which took 10 hours. The return trip only took 13 hours and 20 minutes. How fast was the current moving? So you've got two unknown values there. The speed of the boat by itself, and then the speed of the current. And both those things are affecting how quickly the boat travels up and downstream. So you would write a system of equations to solve that problem.